not, because it seems like it's flat. It's not until we get a bigger perspective that we understand it's not. I think we're going to be dominated by Sentinel. Okay, so I'm going to ask somebody else. Let's ask you guys.
We were asking about how the orbit is similar or dissimilar to Pluto.
Okay. So I didn't actually talk everything about Pluto, so I'm going to start repeating the questions and then answering them, and then the next group can come in. If at some point it raises a question for you, just raise your hand. I want this to be driven by everybody in the room, okay? So the question was, does Pluto have an orbit that's like the planets? Okay. So you guys probably all have an image of how planets move around the sun, right? You've got the sun and you've got the planets, and they're moving around in an orbit that's almost circular, right? It's actually not a circle, but it's almost circular. Pluto's orbit is not quite like that. It's ever so slightly more elongated. So all of the orbits are not quite circular, they're elliptical, they're slightly stretched out. So for instance, for the Earth, we're actually closest to the sun because it goes in this ellipse, so we have a close point and a far away point. Our closest point to the sun is actually in January, okay? And we're furthest away in July. All planets have this. They have what's called a perihelion, close to the sun, and an aphelion, which is far from the sun. But for Pluto, the difference is huge. For the Earth, it's a very small difference in distance from the sun. But for Pluto, when it's at its perihelion point, so it's at the very closest it can be, it's 30 times the distance from the Earth to the sun. When it's at its furthest point, it's 50 times. That's a huge difference. That's a 40% difference between its furthest point and its closest point. So you have this very much different orbit. And that's one of the factors that led to Pluto being considered weird. Let's not say it's not a planet yet, but considered weird.
Does that mean it came from someplace else? Has a different origin?
That's a good question. So the question was, does it have a different origin? It almost certainly still had an origin in the solar system. But I'm going to come on to what it is in terms of, it's slightly different than the planets. And actually it's more comet-like. Okay? So the other thing about its orbit, which is relevant, and so I want to come back to that question, is that you all think of the solar system as being kind of a flat thing, right? You've got the sun, and then you've got the planets going around, and you've got Earth going around like this, and Mars is going around. You don't think of it as being the Earth is going like this, and Mars is going like that, right? They're all going around in this plane. Well, in fact, Pluto is offset from the plane. It's still going around the sun, so the sun is in the middle, but now it's like this. Okay? So it's not going around in this plane that's parallel to the floor, it's going around at an angle to that. So those two things about its orbit are two things that make it very different from the planets. Okay? Now, where does that come from? Why does it have that? Well, when it was first discovered, Pluto was the first thing to be seen out at that distance. But actually somebody called Kuiper, a Dutch astronomer, and don't let anybody tell you it's pronounced Kuiper, it's not, it's Kuiper. I've asked Dutch people to make sure I know how to pronounce it. Kuiper came up with this idea that there must be something like the asteroid belt, but out at the distance of Pluto. Okay? We already had Pluto, but we didn't know of anything else out there. And he came up with this idea that you have this other place that's like the asteroid belt. And the reason that he came up with this was because of comets. Okay? We had a comet come by at the end of last year. We have comets come by fairly regularly. Some of them are spectacular, some of them not so much. But what a comet is a big chunk of dirty ice that is orbiting the sun, just like planets orbit the sun. But they're orbiting in such an elongated orbit. So now it's still an orbit and it's an ellipse. It's a really stretched out ellipse so that it comes in really close to the sun and then a long way out. Okay? But it's a chunk of ice that's maybe 10 kilometers across. So what's that, 6 miles? Sorry. I'm assuming not everybody thinks in metric units. So what you have is, you have this thing, and it's out here, it's really cold, so it's nice and icy. But as it comes in, it starts to evaporate, and that's what gives it the tail. It's evaporating, and the tail is coming off as the ice is evaporating into gas. And so as it comes around, it loses a lot of material, right? We see it because of all that ice that's evaporating, blowing off. That's what's reflecting sunlight, and that's why it looks so much bigger than it really is. But that means that it's going to get smaller, right? It's an ice cube. A dirty ice cube, but it's an ice cube. So as it gets in and evaporates, it's lost some material. And if you work out how much material it must lose, it can only do 100 to 1,000 orbits. Well, think about the comets that we know about. Think like Halley's Comet. Halley's Comet was last found in 1986. It has a period of 76 years. Well, 100 orbits isn't going to take it to the beginning of the universe. You have to have some source of them. So what this guy Kuiper said was, well, actually, you've got this big reservoir. It's a big space out there that's full of chunks of ice. And every so often, the planets will be so that they are pulling, when they're all lined up on one side, they're going to pull more than they're all spread out. And so the gravity is changing, pulling on these things, and they will get knocked into a different orbit, and they'll end up as a comet. So you can have this place where the comet doesn't have to be the whole age of the universe. It can just be 100, 1,000 years since it's become a comet. Okay? And so this was the hypothesis. And the idea was that when you look at these comets, like Halley and the other ones that come back on that period, they are they're all coming from kind of the same plane as the planets, but it's a bit more spread out. And that's kind of what Pluto's doing. It's coming from kind of the same plane, but it's just offset a little bit. And so there was this idea. Well, now we've started to discover a lot more of these objects. So we now know of about 1,000 objects that are out there, and it's called the Kuiper Belt. And it's basically another asteroid belt, but instead of being rocks, it's made of ice, dirty, icy stuff, which is essentially what Pluto is. And so what you've got is Pluto is the archetype, the prototype for these Kuiper Belt objects. And from that point of view, you could consider it to be a really big comet. And I'll come back to that point if somebody asks me the right question. So now you've got all these other objects that we didn't know about when we first found Pluto. And so it almost certainly formed in the same way that the planets formed. But you get the asteroid belt because gravity doesn't let a planet come together. And you get the same thing out at the edge. And so you have all of this icy stuff. And that's what's left over. Okay, so that was a question that came from over here.
Is it in the Kuiper Belt or is it outside the Kuiper Belt?
Okay, so the question was, is it in the Kuiper Belt or outside the Kuiper Belt? It is in the Kuiper Belt. So the Kuiper Belt is defined by basically a zone that goes from where Neptune is all the way out to about twice as far away. Okay, so Neptune is about 30 times further away from the sun than we are. So from that distance out to about 60 times, maybe 100 times. Okay, and it's a big zone that's got lots of objects in it. And when we found Pluto, we found it because it was really big compared to the other objects. The other objects are mostly small. Now that we've started looking, we've found some more. There's one that was briefly called Xena, but is now called Eris. Because, astronomers are nerdy and we like to name things after terrible, terrible fantasy characters. And there's also one called Quawa and one called Make Make. And these are all objects that are kind of the size of Pluto. And they're out there in the Kuiper Belt. Okay? So that was a question over here. Now, let's see. Pick another table over here.
So I have a question.
Go on.
In my naivete. So Pluto is sort of ingrained in our culture as a planet, right? And there are a lot of things that are ingrained in our culture as a planet, right? So we all call cotton swabs that we put in our ears Q-tips, and there are many rivers that are considered called rivers that are actually creeks. So how do you balance the benefit of renaming Pluto not a planet when you have all these other examples all over the place where we keep these sort of non-rational names for things as science? Right,
and actually in astronomy we do that a lot. We have a lot of naming conventions that are downright painful for teachers. So for instance, the planetary nebula has nothing to do with planets. But we keep the name because we've had it for so long, and But I think the difference is that this is about understanding the process of how the solar system is formed and how it's structured. And so if we're going to keep that as a planet, we should also keep Ceres. Ceres is a planet. But it makes much more sense to have Ceres classified in. Those are the objects that it shares its orbit with. And the same is true of Pluto. It makes much more sense to have it classed in that way in terms of our understanding of what the solar system is and how it came to be that way. And so I think there is value in it. I would argue that, if you're going to call a creek a river, if you're actually someone who's studying that environment, you probably don't call it a river. It may have that name, but you would call it a creek, right? So I think in terms of how we understand these things, it really helps us to understand what the solar system is and how much we know about it now to have it classified in with those other objects. But I'd like to make another point, because I don't know that anybody will ask this, but several people in the last year, the decision to devote Pluto was actually made in 2006. And since then, there have been a lot of people who've been very passionate about it. Neil deGrasse Tyson has had hate mail from 6-year-olds. But my favorite one is, people say things like, well, it's in my textbook. It must be true. It was in this book I had when I was a kid. Well, I'm guessing I'm in the middle of the age range in this room. When I was a kid, I was already into astronomy when I was 5. When I was a kid, I had a book that said that Jupiter has 13 moons. Sometime in the 80s, Voyager went past. Voyager discovered that, wow, there are more moons, and now it has 16. So I went from, all my life, Jupiter had 13 moons. And that was huge, 13 moons. And now it's got 16. Now what am I going to do? And then we get better technology, and we can see more and more things. Do you know how many moons Jupiter has at present? Go on, Xander.
Over 60.
It has 62 moons. Okay? So I can find you lots of textbooks that are wrong. And it does change how you then are going to view how did that system get that way. And so I think it's not just a matter of stamp collecting. It's a matter of you have to be able to let go of some of these ideas in order to progress in your understanding of what's going on. Your question.
So is Pluto classified now as a comet?
Some people think there is.
Right now, Pluto is classified as a dwarf planet. So, and I'll talk about that. So I said that it was in 2006 that we decided that we would no longer classify Pluto as a planet. And the press made this out to be, we're demoting Pluto. That wasn't how it happened. What happened was that, and remember I talked in the introduction, we never had a definition for planets, right? We've always had planets. Planets have always been there. There's 6 of them that we know about, and they've always been there. So we never had a formal definition of what a planet is. And so in 2006, the International Astronomical Union had a vote at the General Assembly. The next one is in Hawaii summer next year, if you would like to go. At the General Assembly, they had a vote in which it was decided not whether Pluto is a planet, but what is our definition of a planet. And what we came up with was a planet, and there are basically 3 criteria. It must orbit the sun, okay? So that means that it's not something orbiting another body. That means that all of those planets that we find around other stars are technically not planets. And we use the term exoplanet for those things, okay? It must be big enough to have become round. That's not the word we're using in the official definition. But basically what you have is, the asteroids are kind of potato-like, right? What you get is that when you get these rocks built up of these colliding rocks that are coming together and built up, and you get something that's very irregular. But if it's big enough, the gravity of the body will actually force it to squash itself into a round thing, okay? How big that is depends on what it's made of. So for asteroids, it actually has to be bigger than for Kuiper Belt objects, because rock is stronger than ice, and the ice is easier to make round. So it's not a specific size. It is, can it make itself round by its own gravity? Okay? And then the last one, so Pluto gets both of those. It is round, and it is orbiting the sun. But the last one is it must have cleared its orbit. And that is to say that, you do have other objects in that cross the path. If you've got a comet, it comes past our orbit, okay? But in the case of things like Ceres and like Pluto, there are lots of objects that have overlapping orbits with it. And so that is why it's not a planet, okay? Now, that's the official reason. But if we look at all the things that make it weird, like its orbit and how it sits there with the proto-comets, it was already, I don't know how many of you remember this, but in 2003, Neil deGrasse Tyson came to Columbia and did a talk for Black History Month, okay? And his talk was on Pluto. This was 2003, this is 3 years before the official definition. And he gave a talk on why Pluto should not be classified as a planet. He had already changed the Adler Planetarium before that, okay? It didn't have Pluto in the planets, hence the hate mail. We can go back to, there's a famous astronomer called Walter Baade, who actually has a region in the sky named for him, the Baade window, who wrote an article, was quoted in an article from 1934. Pluto was discovered in 1930. 1934, an article in Popular Science, actually it's Popular Mechanics, that basically says Pluto has been a disappointment. It's more of an asteroid than a planet. It's not like this is something that only came up in the last decade. This has been something that has been bugging people since very shortly after it was discovered. Okay, any other questions? Does anyone want to volunteer? Okay, wait, Devin.
So you mentioned this vote on planet, and that brings up the question with my students. So do scientists vote on every theory or idea?
Is it a theory? It's not a theory. This is about how we're choosing our naming conventions. And the rationale behind it is that you either have something that is massive enough that when it's moving around, if you have an asteroid or something, it's going to be collected, right? It's going to be pulled in and it's no longer there. Whereas the asteroids and the Kuiper belt are not. So there was a rationale for the naming, but it's not a theory. So that's a different thing.
But I think the question is perfectly valid, right? So
Right,
what
right.
she's,
So
what
do we
she's
vote
asking
on-
you is do scientists vote on all changes in classification procedure?
Yeah, well, so the question that it begs is, so did a bunch of scientists get together and vote for evolution, and could enough people
Right.
vote it down?
Right.
But not a democratic vote.
No, it's not a democratic vote, you're right. So, I mean, this was really something where, in part, this is something where I think the difference is that what we're talking about is something that really is a continuum of objects. So you've got objects that are like asteroids, and objects that are like comets, and objects that are like planets, and you have to put a dividing line in somewhere. And so that has some ambiguity, and in that case, they're coming to a consensus on it. The vote is done just so that then there's an official name. But like I say, this is something that I think a lot of people had already come to this conclusion long before it was voted on. But no, the IAU does this in terms of, it was also done the year that we found Pluto, we defined the boundaries of constellations. So if you look at the sky, any star that is found near to Orion is considered to be a star in Orion, okay? We actually defined what is the boundary. And that is why, if you were born in early December, then your star sign is in fact Ophiuchus, the zodiac sign you've never heard of. So, there are some things that the IAU does that is just downright silly. That was also voted on. But that was to do with, this is more about making it, the communication of these ideas easier. And so I think that's different.
So, are there any hyperbelt objects that cross Pluto's orbit?
Are there any Kuiper belt objects that cross Pluto's orbit? Yes. Yes. Many.
What about
There are some objects that come in close to Neptune's orbit. Pluto is a Kuiper belt object. Pluto crosses Neptune's orbit. So in fact, yes. But this is where you get into this gray area, right? So that's why we're saying about there being this continuum. If we really take it that any object coming from the Kuiper belt past the sun, then all comets pass all planets' orbits. So you have to draw a line somewhere.
Do we have any definition for moon? I mean, we have like more than 60 moon for
Right,
Jupiter.
so the definition, the question was, do we have a definition for moons? The definition of a moon is it is orbiting a planet. So, and you can tell that it's not got enough energy to escape, right? It is bound in orbit. It's not going to disappear off.
So it can be an asteroid too.
Well, yes, and in fact, most of the moons of Saturn and Jupiter, and even as far out as Neptune, are captured. So you have something that has come past, but then the gravity of those big planets is so great that it captures them into orbit. And so some of them were formed when the planet formed, but some of them are captured. And that's why they have so many. Sorry? Yes, Pluto does have moons. So this is
Planet.
no. So okay. So this is one of the other classic arguments which made is that Pluto has moons. In fact, it has 4. The big one, Charon or Charon, depending on who you're talking to, is very big, and I'm going to come back to that. But it actually has 4 moons. But if that's the criterion, we're going to say, oh, okay, it's a planet if it has a moon. Well, then we have to throw out Mercury and Venus, because neither of them has a moon. Okay. Not only that, but there is an asteroid which is thoroughly potato-shaped. It's not round, it's a potato, called Ida, and it has a moon that is called Dactyl. So it's not a good definition. It's not a good criterion. Okay? We have another question back there.
Is the material that you can mix up rings count as a moon then? We have ancient moons. Are those moons?
Again, I think that the difference is that the rings would be classified as like an asteroid belt, whereas the moons are like a planet. So that's kind of your difference between them, is that, again, they're orbiting. So for the rings of a planet, it is lots and lots of particles that are orbiting the planet. And Saturn, Jupiter, Uranus, and Neptune all have them. But it's more like having an asteroid belt, and then the moons are more like having a planet. So it's like a mini solar system. So I think there's still that distinction.
Part of his question before about the cultural place that Pluto has taken, because Walt Disney named that dog after it. Wasn't that about the same time? I mean, there wasn't an accident, right?
I honestly don't know. But that's not, I mean, that's not a good reason. It's not.
No, but I'm saying, is that part of
Right,
the reason
so
it's
and
taken
this is
so long?
also
You get-
something
You
that-
get 8 letters from 6-year-olds.
Right, and it's also something that is extremely American. Because it was discovered.
Hey now.
I am an American. Don't. I'm an American. Don't give me grief for it. No, but I mean, so you've only got 3 things that have been considered, well, 4 if you count Ceres, things that have been considered planets that have been discovered. You've got the French and Germans fighting over Neptune. You've got the Brits discovered Uranus and tried to call George, and you've got Pluto, and it's also the only one that was discovered in the 20th century. There's lots of reasons why it has this place in our psyche of being this important thing. I actually think it's way cooler to think of it as being this asteroid thing, and I don't think anybody's going to ask me the question that lets me get to it, so I'm just going to talk about it.
So does that mean it's a uniquely American problem with the demotion of Pluto? Or?
I think that Americans, the American public has a bigger issue with it than the public in other countries.
I want to hear what the question is you're going to answer.
Well, so basically, the question, one of the other things that people bring up, in fact, I'll digress very slightly. So there are things that people talk about as the reasons why Pluto should be a planet. Actually, apart from the moon one, my other favorite is, but we're sending a probe to it. Okay, so right now there is a probe that is visiting Ceres and Vesta, which are asteroids. We have sent 6 or 7 probes to comets. In fact, there's one that just woke up after being in deep sleep for a long time that's on its way to a comet to land on it and sample it. Okay, we've sent probes to lots of things that aren't in fact planets. And the mission, New Horizons, that's been sent to Pluto, is actually a mission to investigate the Kuiper belt. So, definitely a Kuiper belt object. But the question that nobody's asked me is about atmospheres. Do all planets have atmospheres? Do all planets have atmospheres? So Mercury does not have an atmosphere. So that's not a good criterion anyway, okay? But it presents us with another thing that's really interesting, which is that Pluto has an atmosphere some of the time. So let me get into that. Remember I said that if I'm the Sun and Pluto is going around me, when it's its closest point it's here, when it's its furthest point it's over here, okay? So whereas for us, it's equidistant, more or less, we're very slightly closer in January, so it doesn't make any difference to our temperature. But when the difference is 30 or 50 away, it makes a difference, okay? So when Pluto is all the way over here, it's completely frozen. Remember I talked about the comets? You've got these big chunks of ice, and as they come in towards the sun, it starts to evaporate. That's what happens to Pluto. You have this material that is ice, and as it comes in, it's getting warm enough that that ice evaporates and it becomes a gas. For a comet, this gas streams off away from it. The comet can't hold on to it. It's not got enough mass. It streams off. But actually for Pluto, when it's further away, you can't actually, there's nothing coming off, it's too cold. When it gets to its closest point, it has an atmosphere. And as it moves away again, the atmosphere disappears, either because the ice, the vapor condenses back down to being ice again, or it's just escapes, because Pluto is not that big, it doesn't hold on to the gas very well, okay? So in fact, in its orbit around the sun, it's going around like this. It's doing the same thing that comets do. It's doing exactly the same thing that comets do. Comets come way in past stars and sometimes past Mercury, but Pluto is doing the same thing. So I would argue that Pluto is in fact the biggest comet in the solar system, and not a planet at all. There was another question about that.
Wouldn't you be able to tell from its orbit whether it was losing mass or not?
No, but that's a good question. So one of the things that is tricky is the mass that it's losing is small, right? And if you actually go, I don't have a board, so I can't go through the equations, but what really matters is the mass of the sun. For the orbit, the mass of the sun is all important. The mass of the orbiting object is negligible compared to the mass of the sun, so small changes really don't make any difference. It would have to be a huge change for it to have even a small difference. So that doesn't help you. Now, if it's losing mass and it has moons, then the moons would be affected because that's what's causing their orbits, right? And so you might be able to use that, but the amount of mass it's losing compared to its total mass is small. Because remember, it's not like these chunks of ice that are coming all the way in. It's only coming in a little bit. So it's still something that's at the level of within the noise. It's hard for us to measure that. But
So what is the composition?
composition?
You're calling it ice, is it?
So it's basically more or less 1/3 water ice and 2/3 rocky stuff.
2/3 what?
Rocky stuff, so silicates. So it's basically something that is, you've taken a bunch of gravel and mixed it in with a bunch of ice. And that's what it's doing. So it's got a lot to lose.
Is it possible for a comet to have a satellite?
Well, that's a good question, because we don't, how would we see that?
You suggested that the Pluto was a comet.
Right, so I don't think, so the problem is that I think that when we see comets, remember that they actually have to come in relatively close before we start to see them. So they've already gone through a lot of disruption, so they may have had a moon further out. Pluto isn't coming in that close. We see it because it's big, yeah? So I don't know that, we've never found a comet with a moon, but it's going through a fairly violent orbital thing, that if it had a moon, it would be affected. And they're only about 10 kilometers across. So the moon would have to be something smaller. So that's tricky. But it doesn't mean it couldn't have happened when it was living out in the safe zone.
Is there any indication that we know of that Pluto might have had more than 4 moons at any time?
I don't know how you would check that.
Okay.
So, when we find, Pluto and Charon we've known about for quite a while, but it's only in the last decade, and in fact in the last year that we found the last one. But the last decade we found the other two. You know, this is something that, unless, it would be very hard to detect. It would be like, well, you know, there's this thing that's going around in the solar system, and well, maybe it was, you know, going around the Earth sometime in the past. That would be very hard to actually trace back. So, do I have any other? Oh.
You mentioned that there's a lifespan
for comets.
So, how much longer is Pluto expected to last?
Okay, so the question is that since comets have a lifespan, how much longer does Pluto last? So normally comets are much smaller and they're coming in so much closer that they're losing their mass really fast. Whereas Pluto is very large, and that helps it keep its mass because it will tend to suck it back down when it starts to freeze rather than have it ejected, right? Whereas a small thing, it doesn't have much mass, the gravity is low, it's easier for it to lose the mass. And it's not coming in all the way towards the sun, it's only coming in a little bit. So its mass loss is very, very low. It will not disappear on the time scale of the lifetime of the sun. So the sun will die before Pluto would be destroyed from that mechanism.
So do its moons actually orbit the planet, or the dwarf planet?
Okay, so the question was, do the moons actually orbit the planet? Okay, I need small children probably. No, they're calm. I need 2 volunteers. Come on. All right, so I'm going to have, so you're going to be, well, let's start off with Earth and Moon. So when the moon goes around the Earth, what happens? So why don't, Matt, you stand here, and Allie, the orbit. Right, okay. Now I'm actually going to ask you to do that. So you're actually more or less doing it, but try to keep your, no. So when the moon orbits the Earth, it's actually always facing, no, it's not spinning, it's always facing. So it's actually spinning around, but it's spinning around at exactly the same rate that it's going around. So it always keeps one face towards it. And that's understood from the physics of time. Now,
the opposite.
now I would like you to be Pluto and Charon. And Charon is the biggest one. Charon is so big that it's actually about 1/10 of the mass of Pluto. So it's really big. Now face each other. Now, the center of gravity is actually somewhere in between the two. Okay, so you have to walk around so that you're both facing each other. No. You have to walk around like this. So basically what you've got is you don't have a planet. Yeah, so it's like a binary planet. They're two going around some point in between the two. They're not actually, thank you. So you have these, the moon, the biggest moon and Pluto are going around each other, not a moon going around the planet, right? And so that's another thing that is unique. It's something that we don't see in any of the planets. Okay, have I exhausted you all yet?
One more. So if the orbit of Pluto and it's always facing the sun and it's going.
Pluto is not always facing the sun. Pluto and its moon are always facing each other.
Okay.
So Pluto isn't close
just
enough.
from a general sense, how much time does it spend in a period in which its ice is melting?
Okay.
Versus when its ice would be sucked back in.
Okay. So the period of the orbit, so the time it takes to go all the way around, is 248 years. The time that it's going to spend with an atmosphere because it's actually evaporated some, then that is only going to be less than a quarter of that period. So it's doing it for the bit where, so less than a quarter of the time it's going around. Now, part of it is, and this is something that is really interesting from the point of view of how long we have summer and winter. When you're closer to the sun, you move faster, and when you're further away from the sun, you move slower. So when it's closest, it's going through that bit of its orbit much, much faster than the long end of the orbit. So in fact, like for us, we're closest to the sun in January. So we're actually going through that bit, our winter time, we're going through that bit faster, and we go through our summertime.
Can we go faster?
Unfortunately, it's not helping, right? And so, yeah, so it's about a sixth of the orbital period, but it's more like a quarter of the actual length of the orbital.
What do I tell my neighbor when he asks me, why are we wasting all this money on astronomers? I said it wasn't me.
So, I mean, I think it would depend exactly how we phrase it, but one of the things that I think, there are several aspects to astronomy that I think are really important. One of the things is that we actually get to test ideas. So Newton came up with his ideas from planetary orbits, and not, you can't test his ideas so easily, or you couldn't at the time, without having that system. There are all sorts of other things that we're able to test. The things that we do allow us to extend the idea of science, and we don't know what the outcome is going to be. We don't know which bits of science are going to lead to the really important discoveries. And we don't know, especially amongst the people who are aspiring to be scientists, astronomy is something that appeals to people because there are these beautiful images, everybody looks at the sky. And so it's a way to bring people in, and you have to understand a lot of physics and a lot of math, and have them learn about that, and then go on to be the next leaders in something completely different science. But astronomy itself also comes up with discoveries that are important to us, and you have to fund all the different types of science, because you don't know where that next is going. Okay, any other questions?
For students?
Sure. All right, you can get off the stage.
Thank you.